Hey kiddos, today we're going to be talking about determining if something is a function using the definition of function. So super easy process. We're going to review the definition of function now. Remember that a function is a relationship where each number in the domain matches up with exactly one element in the range. So basically what that means, if you remember the definition of domain and range, domain being x values and range being y values, is that for every x value, there's only one y value. Okay, so for every x, there can only be one y value that it matches up with. So if you consider this situation, so here is a situation where Tony and Sasha are plugging in different numbers into a function. 1 produces 5, 2 produces 3, 3 produces 25, and then 1 produces 11. We have this weird situation where 1 can result in 5, or 1 can result in 11. So 1 has two possible outcomes, and we don't know which one it's going to be. So that's an issue because it violates that definition of function where every x can only link up with one y. So what we're going to do is we're going to use this definition to determine if something is a function based on two things, mappings and a picture of the graph. Okay, so looking at our first discussion of is something a function, we're going to be talking about mapping. So mapping is the idea that we have our domain and range or x, y, or input output listed on separate sides, and then the arrows are discussing how those are connected by the ordered pair. So if you were reading this, the one on the left, you would say 10 goes with 15, so that ordered pair is 10, 15. 20 goes with 45, 30 goes with 25, 40 goes with 35. Okay, now based on the notes on the top, every number in the domain has only one line. That means it's a function. So let's look at the object on the left. So 10, 20, 30, and 40 each only have one line coming off of them. So that means that every input only has one possible output. So yes, this would be an example of a function. Now let's look at the object on the right. So any number in the domain has multiple lines. So if we're looking right away, I can see that 2 has two possible outcomes. 2 can either be 20 or 2 can be 40. So this would not be a function because 2 has two possible outcomes, two values that it matches up with. So that violates that definition that every element in the domain only matches with one element in the range. Okay? Now, if we were doing this from scratch, like in this example, we have our ordered pairs and we would have to create the mapping. So what we're going to do is we're going to remember two things for making a mapping. The first is that you write the numbers in order from least to greatest. And the second is that you always omit repeat. So you don't write a repeat. If it happens twice in the domain or the range, you don't write it twice. Okay, so let's go forward and do this. So domain, we're looking at our x values first. So I have 2, 4, 5, -4, and 3, and I want to write those in order from least to greatest. So we're going to start with -4. And then I have 2. And then I have 3. And then I have 4. And my greatest value is 5. And again, I underline things just to make sure I've counted for them. I always want to underline things to make sure I don't forget one. Now I'm going to go through and do my range. That's my y value. So I have 3, 3, -2, 3, and 0 in order from least to greatest, starting with -2. And then I have 0. And then I have 3, which happens 3 times, but again, I only write it down once. Okay? And now, looking at the ordered pairs, I'm going to connect domain and range based on the ordered pairs. So 2 matches up with 3. 4 matches up with 3. 5 matches up with -2. -4 goes to 3. and 3 goes to 0. Now again, we look at the domain. Definition says every element in domain can only match with one element in the range. So looking at the domain, 1, 1, 1, 1, 1. Every element in the domain only has one possible outcome. Now, a lot of students get confused and they would look at this right here and say, well, that doesn't match up with the definition. But remember, the definition only talks about elements in the domain. So this is the only place I have to look, okay? I'm not worried about what's going on with the elements in the range. Every single element in the domain could match up with the same element in the range, and that would be okay, as long as each element in the domain only has one possible outcome. So yes, this does represent a function. Okay, let's look at another example. So here we have another set of ordered pairs, and we are going to do the same thing. We're going to list out our domain. Those are our x values. So 4, 5, 5, 6, and 1 in order from least to greatest, starting with 1. Then I have 4. Then I have 5, which happens twice, but I'm only going to write it once. And then I have 6. Okay, now let's do our range. Range is the y values. 1, 2, 3, 6, and 9. And those are already in order. 1, 2, 3, 6, and 9. Now, I'm going to, again, draw the lines to show the ordered pairs. So 4 matches with 1. 5 matches with 2. But 5 also matches with 3. Okay, 6 goes with 6. 1 goes with 9. Now, right here, this is a big no-no. 5 has 2 possible outcomes. 5 can be 2 or 3, and that's not okay based on the definition of function. So no, this would not represent a function. Again, we look at the elements in the domain. If any element in the domain has more than one line, it is not a function. Okay. Second and last skill would be determining if something is a function based on the graph. So we use something called the vertical line test. Vertical line test is super easy. You just draw lines going straight down. Now, if those lines touch the graph more than once, then it is not a function. Okay? So let's look at 3 examples. Here are 3 pictures of graphs. So we're going to draw a vertical line going straight through. You can draw multiple lines. Okay. Now you'll see that each green line that I drew only touches the red picture of the function one time. So this is a function. Okay, same thing over here. We draw vertical lines. Anywhere you want, you just draw a line going straight down. Okay, my pen made it look like that. This diagonal line shouldn't be here. Okay, there you go. And each of these green lines only touches that graph once. So yes, this is a function.